Now this video is the conclusion to a series in which I showed you how to develop an automatic night light circuit from the initial idea through the individual functional groups up to the finished circuit, which we're going to look at in this video. And in the last videos you have seen how to measure a light sensitive resistor and how to generate a switching signal using an operational amplifier in comparator mode depending on the light level intensity. You have also learned how to control a light emitting diode using a transistor as a switch, and in this video we will look at how to connect all these individual components in order to perform this switching operation and to look at the complete circuit. And in case you have any questions, as always, drop them into the comment section down below. And now enjoy the video. Now first, let's look at the content of the video briefly. We're going to look at the nightlight wiring diagram, then we're going to connect the components together, and then we're going to test the entire circuit. Now let's take a look at the block diagram which we have used so far. We have a power supply. This supplies all the modules with electric power. The second module here is on measuring the light-dependent resistor value, and the potentiometer here is used for adjusting the level of voltage division between these two components here. And then the third module here checks the switching condition using an operational amplifier. And the switching operation then triggers this transistor here, which switches on the LED, or could be anything else. Could also be a motor which we could switch on, or a relay which could trigger a light bulb. So the applications for this are very manifold. And now let's look at the wiring diagram first. The complete diagram with all the components looks like this. We have the power supply, we have the LDR, we have the potentiometer, which is simply used as a variable resistor here. Then we have this fixed value voltage divider, a 10K and a 5K resistor. We have the operational amplifier, we have the transistor here, the NPN transistor on the right. This resistor here limits the current flow to the base. This LED here is switched on and off depending on the switching condition of the transistor, and this resistor here limits the current flow through the LED. And now let's try to build this circuit and see how the entire circuit, the entire nightlight behaves. Okay, this is the final video in which we assemble all the components we had previously discussed, and the aim is to use a light-dependent resistor here which reacts to changes in the ambient light to trigger a light bulb here, an incandescent lamp, which is driven by this relay here. We haven't talked about this component yet, so this is new. I'll get back to it in just a few minutes, but let's briefly discuss the other components here. So the first breadboard here contains, and there's an individual video on this breadboard here, contains the light-dependent resistor, contains the potentiometer, which is used to balance the voltage in between these two. So we have one point here in between, which generates a voltage, or which is driven by a voltage split between the reference value here adjusted by the potentiometer and the resistance value which is directly related to the ambient light falling onto this surface here. And this reference point is compared against the reference voltage in between these two fixed value resistors here. And in an ideal situation where we have exactly balanced the Wheatstone bridge, which this is, this measurement bridge, to have exactly 0 volts across it, then we can use the operational amplifier here, which is used as a comparator up here to react to this voltage difference between these 2 points. So the idea is to use the yellow cables to go into the entrance of the operational amplifier, and as soon as we darken the light-dependent resistor like so, the voltage difference between the 2 entrances here becomes positive, which triggers the output, and the output leads to the resistor, which you can see here, and back to the negative terminal of the battery. And as soon as the light difference becomes positive, which happens when I block out the light, this LED will shine, and also this voltage level which we have at the output of the operational amplifier is transmitted to the third component here in our circuit, and this is the
transistor, which we previously used to light up an LED, which we now use to trigger a relay connected to an incandescent lamp here. And this green cable here comes from the output of the operational amplifier, leads to the input resistor of the transistor here. And as soon as there is an output voltage here, which is generated by the LDR, the current running into the base of the transistor connects the collector to the emitter. We have a current flowing, and this current is what's driving, alongside with a voltage drop of course, is driving this relay circuit here. And the idea of this relay circuit, I'm going to make a video on this in a few days, but the idea of this relay circuit is to trigger a second circuit. And we have the entrances to the relay here up top, the red cable and the blue cable. This triggers this switch. Relay is nothing else than a switch, and it connects the red cable, or the red bridge here, with the blue bridge over here. And in this closed circuit, we have the blue incandescent lamp, which is powered by a different battery. This illustrates the fact that we are switching between two circuits. We have the circuit on the left, we have the circuit on the right. The circuit on the left is triggered by our setup here. The circuit on the right contains a different energy source. Could also be another battery. It could be the wall socket, but for using the wall socket we would need another relay, which is suited to 230 volts of power in the German net. This one is only suited for 30 volts, but basically we could do it in this manner, and this then lights up the LED. So we are switching another circuit by using our setup here. Now let's test this entire setup, and I know this has been a very quick walkthrough, but we talked about each individual component in a separate video, which I link below the video description here. And this one here is going to be explained in detail in a few days. What I want to show you now is, as soon as I connect the power cable to this first circuit here, now let's twist the individual wires a little bit more. Now everything is powered, and we can put our finger across the light-dependent resistor here, and you can see that the LED switches on, which means the output of the comparator of the operational amplifier goes to high. This signal is transferred to the base of the resistor. The resistor becomes conducting, starts to conduct between collector and emitter, and this current, which is running from the positive power rail here through the relay setup of the relay circuit here and back to the transistor, this is what drives the relay switch, which then in turn connects the second battery to the incandescent lamp. So if I put my finger away, you can also hear a click, which comes from the mechanical contact being open and closed. And as soon as I put my finger back here again, the night light switches on, switches off, switches on, switches off. In case you're wondering what this diode here, or what this element here does, this has not yet been discussed. This prevents energy which is stored in the coils of the relay to output the energy unhindered, unchecked through the rest of the circuit, which could damage the transistor. We will look at the energy storage in coils in a few days by using an oscilloscope. But for now, the only thing you need to know is this is needed. If I put this one out here, I am endangering the transistor, which I do not want to do here. So this is our first project. I hope you were able to follow through the path of the current and also the functionalities of the different components. I know this is a lot of wiring here, and my hope is that by watching the individual videos you will be able to understand what has been going on in between these modules here and how they have been connected. If you have any questions, drop me a comment down below the video, and as always, I wish you a nice day. See you next time here on The Fearless Engineer.